Hello and welcome to a new video. This is for pre-algebra using the Math UC curriculum, and in today's lesson we're going to talk about ratio and proportion. This is lesson 19 in Math UC. So let's first talk about what do those two words mean, ratio and proportion. Ratio is one of the words we use in place of fraction. And to me at least, it seems like we normally use ratio when we actually are talking about a connection between two numbers. So whereas fractions, we could be talking about half of something, like half of a pizza. Ratio would be that we're talking about, having this amount out of this amount, or having this amount compared to this amount. So one example of that might be if you count the number of girls and boys in your math class. Maybe there's 10 girls and 10 boys. So we could talk, it's not a very interesting ratio. We could talk about the ratio of boys to girls or the ratio of boys to the total number of students in the class. And so to me, what makes that seem more like a ratio than just a fraction is the fact that we are putting a connection to both numbers. Whereas like half, when you talk about half of a pizza, the one half all goes together with the pizza. It's not the one and the two are two different things. It's still talking about pizza. I don't know how much sense that makes, but there are definitely going to be some word problems that we look at in this section that will maybe help you see what I mean by that. That ratio, we tend to be talking about actual numbers of things that we're comparing. A proportion is an equation that's made up of two fractions. And so what you'll have is you'll have a fraction on either side of an equal sign. And a proportion shows a relationship between these two fractions. Because in order for two fractions to be equal, they have to be equivalent fractions. That's a term that maybe you heard when you first started learning about fractions, that, we might have a fraction like 1/2, but we can write that fraction in many other ways and have it be equivalent. We can say that it's 2/4, for instance. What I've just written is actually a proportion because I have a fraction on the left and a fraction on the right. It's an equation. I'm showing that there's a relationship between these two things, that they are equivalent fractions. So what we're going to do today is we're going to learn how to solve proportions. And there are 3-ish methods. I really only like 2 of the methods, and so those are the 2 I'm going to show you, unless I randomly change my mind and decide to show you the third one. We kind of already know the third one. The third one is actually where you, if there's a number underneath a variable, right, we can just times by that number on both sides and figure out what it is. So there you go. That's the method that I wasn't sure I was going to tell you about. Let's look at example 1. Solve for the unknown using whichever method is most convenient. Sometimes in math, especially like later on in math, you'll be asked to do something a specific way, and that's to test that you can do it that specific way. But in this case, we want to pick the way that seems easiest at the time to do. So there's kind of 3 different ways we can do it, and the easiest way to do it, if it works, is to compare the numbers you know. So because we know 3 and 12, we can say, how would I change 3 into 12 using multiplication? Or can I do that? And if the answer is yes, how would I do that? And then we do the same thing to the other one to help us find what the variable is. So here's what I mean by that. If we can say, I know that 3 times 4 is 12, then that means that the same relationship has to be happening on top as well. So we do 2 times 4 to figure out what A is. That means that A equals 8. So that's our answer. One of the other ways to do this that I think is also not too bad is that we could have said, well, there's a 12 underneath A, so we can actually multiply both sides by 12 over 1, and that will also solve it because it cancels out the 12, so that we just have A, and then we'd work it out on the left side to see what that ends up being. 12 over 1 times 2 over 3 would be 24 over 3, which simplifies to be 8. So either way you want to do it is fine. I really like the way where we look for connections because I like finding those connections in numbers and things like that. So, but sometimes it is hard to tell what the right answer might be. Not only that, but as we'll see on example 2, sometimes it may feel impossible to find the connection, at least without a calculator. So here, b is on the bottom, that's okay. We can look and say, is there a thing I can do to get from 4 to 7? 4 times what is 7? Addition is not something we can use here. It has to be multiplication. So I don't know what I would multiply 4 by to get 7, and I'm pretty sure it would have to be a decimal or a fraction. So instead of doing that, what I want to do instead is this really cool method we have called cross multiplication. Cross multiplication says if you have two fractions that are on either side of an equal sign, we can multiply the top and the bottom, the top of one with the bottom of the other, and then do the top of the other with the bottom of the first, or however you want to say it. Like we multiply across in like an X, and basically it gets rid of our fractions. So we do 4 times b, which is 4b. Then we put equals, and then we do the other multiplication, 7 times 5, which is 35. And we divide both sides by 4 and get b equals. Now there's 3 ways that we might choose to write this. We could technically leave it as 35 over 4. We could change it to a mixed number. So that would mean saying, how many times does 4 go into 35? It goes 8 with 3 left over, so that's 8 3/4. Or we could write this as a decimal, which to me is easiest to figure out once I already have 8 3/4. The other way would be to put it into a calculator, which I'm not a super big fan of, but 8.75 would be that decimal. The answer, I guess, that I like best personally at this point is the 8 3/4, but just know, if you know how to figure out if your answer is right, if they give you a different one of these answers, that can be super helpful. Because it's frustrating to look at an answer and be like, well, that's not what I got, and then later to realize that it means the same thing, you know. Okay, anyway, so that's kind of the gist of the methods we have. I have 2 more examples, and then I want to kind of talk through a word problem that we might have. So you have to basically look at this and say, okay, which method makes the most sense to me? Cross multiplying always works, but sometimes it's faster if we can figure out the pattern. I also want to say cross multiplying is something that we'll see later on in Algebra 1, Algebra 2, Pre-Calculus, however high up in math we go. So it's a really neat skill to have no matter what. And it feels to me, from my experience, like most people end up being fairly positive about cross multiplication. I think it's very straightforward. You just multiply across. It gets rid of fractions, which is always a good thing. So hopefully if you give cross multiplication a try, you'll decide you like it as well. So let's look at example 3. Solve. Okay, let's check to see if there's a connection here. Is there a way to go from 10 to 40? And if so, we're going to do the same thing on top. So 10 times what equals 40? Well, that's kind of unfortunate. That's another times 4, and that happened to us earlier. But this is a little bit different because we're saying x times 4 equals 20. So we actually have to go backwards. We have to say, in order to get the numerator for the smaller fraction right, I'm going to have to do 20 divided by 4. So that means that x would equal 5. Another thing we can do to help is if you notice that a fraction can be simplified, you could do that. Like 20 over 40 is a half. And so I don't know if that would have made it easier for us to figure out or not. But it's certainly something that's an option. We could have cross multiplied and we would get the same thing. In general, if your answer ends up being a whole number, you could have figured it out using this thing where you look for the relationship. If it isn't a whole number, then you probably had to cross multiply. There's probably some decimals that you'd be able to figure out, but not that does end up being tougher. Example 4. So we have 9 halves equals y over 5. And so maybe you can think of 2 times what gives you 5, or maybe not. I'm going to go ahead and cross multiply so we have another example of that. So we're going to do 9 times 5 equals 2 times y, which 9 times 5 is 45. And then we're going to divide both sides by 2. Now we could say this is 45 over 2, or we could change it to a mixed number. 2 goes into 45 22 times, because that's 44, so 22.5, or 22.5. So whichever one of those ways that you want to write it. So the other thing is we are going to have word problems related to this, where we talk about ratios and things like that. And so I want to give you an example of how that might look. Okay, so here's an example of how they might give it to us in a word problem. The ratio of boys to girls in your math class is 2 to 3. If there are 10 boys, how many girls are there? So one of the things that is helpful is not just to set up the numbers in a fraction, but to say they're talking about the ratio of boys to girls. So everything they say after that is going to give us something related to boys on top first, and then something related to girls second. So the order they list it when they say ratio, that matters. So the ratio of boys to girls in your math class is 2 to 3. So when we set up 2 over 3, then we think 2 goes with boys, 3 goes with girls. Then it tells us that there are 10 boys and asks us how many girls there are. So what they're saying is there is a connection between this 2/3 and figuring out how many boys and girls there are. We can cross multiply, or we can see if there's a relationship we can figure out. Here, this would be that 2 times 5 is 10. So 3 times 5 would give us 15. That means that x equals 15. And since it's a word problem, we take a moment to say, what did we just find? So we found how many girls there are, so our answer is 15 girls. The other way they can give you ratios is, instead of saying the ratio of boys to girls or something like that, they could have said the ratio of boys to the total number of people. Okay, so just pay attention to what they're telling you and then think through how that's going to impact the way you set up your fraction. But in general, if you're talking about two different things, you want to make sure that on the top of any fraction you use, you have the same things on top, so related to boys each time. And on bottom, you want it to be the same relationship, the same item or person or whatever on bottom the whole time. Thanks so much for watching. I hope you enjoyed this video, and I hope to see you again in another one. Please leave me a like and go ahead and subscribe if you haven't already. And I'll see you in the next video. I think I said that already, but I really want you to watch the next video. I'm sure it's going to be really great. Thanks. Bye.